everyone, this is lesson 4.2, Congruent Triangles. Today we are going to identify and describe congruent triangles and identify corresponding parts of congruent triangles. So think what it means for two triangles to be congruent. What does that word mean? Okay, congruent means that two shapes have the same angle measures and the same side lengths in corresponding order. So a lot of you have learned about this as same size, same shape. Same size meaning side lengths, and the same shape meaning angle measures. And they have to be, the side lengths and the angle measures have to be the corresponding congruent angles and sides have to be in the correct order. If they're not in the correct order, then doesn't count as being congruent. So today we're going to talk about what it means for two triangles to be congruent, how to name corresponding parts, and how to write a congruent statement. So two triangles are congruent if and only if their corresponding parts are congruent. By parts, we mean sides and angles. So another phrase for this, which we're going to talk about a little bit more in detail in another lesson, is that corresponding parts of congruent triangles are congruent. CPCTC, that's the abbreviation we will use for this theorem that we will be learning about how to use in a proof in another lesson. So basically, the corresponding parts, corresponding sides and angles of a congruent triangle are also congruent. That might sound a little funny to you right now, but we will talk about that in detail later. So when writing congruent statements, a congruent statement is when you say that one triangle is congruent to another triangle, or an angle is congruent to another angle, or a side length is congruent to another side length. So you always write the corresponding vertices in the same order. So look at these two triangles here. If you look at the angle markings, it has one arc. So which other angle over here in this triangle has one arc? You can see I and O. So I and O would be the congruent angles together. And then G and M have two arcs, which means that these two angles are congruent to each other, but they're not necessarily congruent to I or O, or E and Q. And then E and Q have three arcs, so those two are congruent. And then the same thing with the sides. So if we want to call two side lengths congruent, we would give them one tick. If we want to specify another pair of congruent sides that are congruent, we would give them two ticks rather than one tick to tell the difference. And then if we have a third side, we would give them three ticks. If you have a quadrilateral or something with more than four sides, you can use 4 ticks, 5 ticks, 6 ticks. I start making squiggles instead of ticks, or like X's instead of ticks if we get to just more side lengths. That way it's less confusing. But so let's write congruent statements for the triangles. Now, if it says to write a congruent statement, a triangle congruent statement, you will say that the triangles are congruent. So triangle, and we're just going to name it, and you can name it alphabetically, or what I'm going to do is name it based off of the arcs and then go in the order. So one arc, two arc, three arcs. I, G, E. I, G, E. And then is congruent to triangle, and then we would name the same order, O, M, Q. Okay, even if this triangle were maybe flipped around or rotated or reflected, we would still name it OMQ. Okay, so sometimes it might trick you, and the corresponding vertices aren't necessarily in the same location of the plane as the other triangle, so you have to be careful when you're naming the corresponding parts. All right, so then let's name the angles. So we should have three statements for the different angles because there are three angles. So let's just start off with, actually, if we look at the triangle statement, you can actually tell because we named it in the order of the vertices. So I and O are congruent, angle G and M are congruent, and angle E and Q are congruent. So angle I congruent to angle O, angle G congruent to angle M, and angle E congruent to angle Q. Okay, so you can either look at the diagram or you can look at just the vertices of the triangle that we said were congruent in number 1. Okay, and the same thing with the sides. So you can go ahead and look at the sides here in the diagram, but you don't necessarily need the diagram if you have a congruent statement for the triangles. So we can say that IG, side IG, or leg IG is congruent to side, and then the corresponding vertices on the other triangle would be OM. Okay, and then we should have three total. So let's do GE and MQ. GE congruent to MQ. And then let's do IE and OQ. IE congruent to OQ. Okay, now you might be wondering, do you have to name it like in reverse order, like GI and MO? No, you do not. Those mean the same thing. However, what you don't want to say is, for example, that IG would be congruent to MO. You don't want to say something like that because you're not listing the vertices in corresponding order. So I and M are not congruent, I and O are congruent. So these two should be flip-flopped. Okay, so maybe write that down, put an X through it so you remember to not write it like that. Also, if you have a more complicated triangle in a larger diagram, you may not be able to just use one vertex. You might have to name it using the 3 angles. Okay, you can usually tell when an example like that is given, when it's not just one triangle and another triangle. I believe we will see a couple examples like that here. All right, and then the third angle theorem says that if 2 angles of one triangle are congruent to 2 angles of another triangle, then what can you conclude about the third angles? So, for example, you have 2 triangles here. You know that these 2 angles are congruent, and you know these 2 angles are congruent. So what can you tell about those 2 angles? Well, they are also congruent. Kind of obvious, but so for example, if this angle was 60, if this angle was 20, so this angle would be 60 and 20, then this angle would both have to be 100 because of the triangle sum theorem that you learned in the last lesson. Okay, now, this is an important question. Does this mean that the triangles are congruent? Does this mean that the triangles are congruent? Does it? What do you think? Answer is no, because they could be similar. So similar triangles are triangles with the same angle measures, but one could be smaller than the other. So they may have different proportions, or maybe the same proportion, but different lengths. Okay, so they would, if all the angles are congruent, then they are proportional. They are similar, but they might be smaller than the other. Okay, so let's look at a few examples. Write a congruent statement for each of the following figures. So number 1, let's start with, how about point G here? So let's name this top triangle G. And let's go up to the right angle. So GDE is congruent to triangle. And then which angle would be corresponding with angle G in this triangle on the right? GDE F, or E. So actually it's going to be E. So notice that angle DGE doesn't have an arc. Neither does this angle here. So that would be the corresponding angle. So E. And then we went to the right angle here to G. So we're going to D. So now we're going to go down to F. So EFG. All right, here, these aren't triangles, so we're not going to preface it with a triangle symbol. We're just going to say, we'll go 1 tick, 2 tick, 3 ticks, 4 ticks. So C, D, E, F. So C, D, E, F is congruent to, and then same order here, H, I, J, K, H, or just H, I, J, K. All right, so what about here? So we've got these two triangles are overlapping, and you'll probably see this kind of triangle again here because they overlap such that the overlap becomes an isosceles triangle. So that's kind of an interesting problem there. But anyways, how would we name the triangle? Let's start with Z down here. Let's go Z, T, and then X. So triangle Z, T, X is congruent to, and then how would you name the other triangle with the corresponding order? So this would be W, V, Y. W, V, Y. And then back to W, but you don't have to say W again. Okay, some questions down here. Triangle TJM is congruent to triangle PHS. Complete the statements. So before I even complete these statements, I'm going to take this congruent statement and apply it to my diagram here. So TJM, I'm going to give those arcs. So T gets 1 arc, J gets 2 arcs, M gets 3 arcs. And then I'm going to do the same arcs with PHS. So P gets 1, H gets 2, and then S gets 3. So now I know that angle P is also 73 degrees, and then M is also 48 degrees. 48 degrees. And then 5 centimeters SP is going to be TM down here. So 5 centimeters. All right, so now angle P, we found out was 73 degrees. JM. Let's see. Oh, okay. It's just saying what is JM congruent to, not what the measure is equal to. Careful. Oh, okay, sorry. Careful. Back up. So it's saying angle P is congruent to what other angle, not what the measure is. I apologize. So that would be angle T. And then here it says what is the measure of angle P? That would be 73. And then segment JM is congruent to segment, and then name it in the same order, would be HS. And then what's the measure of angle M? That would be 48 degrees. What's the measure of MT? Because when it has no segment symbol on top of it, then we're talking about the measure. So that would be 5 centimeters. And then triangle HPS is congruent to, now this is the same triangle over here, it's just flipping the order of the vertices. So one thing we can do is just look at the other triangle name up here and list the corresponding vertices. So H is in the middle, J is in the middle, so we'll start with J. And then next is P, so we're going backwards. So T would be corresponding with P, and then S would be corresponding with M, so JTM. All right, and then some more problems. Solve for the variable. So here, let's see. What do we know here? We know that this end would be 70 because they both have 2 arcs on them. And then we know that the angles in the triangle add up to 180. So we can do 60 plus 70 is 130 plus 2x equals 180. So 2x is 50, x is 25. 11. Okay, so we have to have we have a triangle congruent statement up here. So let's take a look at that first. So BCA, I'm going to do tick marks here instead of arc measures. So BCA, it's congruent to EFD. So E down to F, over to D. So 2 and then 3 for the last one. Okay, so one first equation we can set up would be that 5x plus 2 is equal to 87. So then 5x is 85. 85 divided by 5 is 17. And then to find y, we have to do a little bit of work here to find y, because we need to know what this angle measure is. So one thing you know is that over here, this would also be 42. So you can use triangle sum theorem then for this triangle to find the y. So 87 plus 42 would be what, 129 plus 3y equals 180. 3y would be 51, right? 51. And then what is 51 divided by, I'm going to need my calculator for this. It's too early for this kind of math. All right, 51 divided by 3. 17 again. Okay. All right, next question. We might skip a couple of these. Let's see. So this is, number 12 is another one where you have to use two different equations. So first you would set up that 51 is equal to 6a minus 3. And then you're using a different color to denote this. This would be 83. And then you would try to find what this angle measure is, set it equal to 7b minus 10. Okay, so that's not a novel solving equation. So I'm going to skip that one for now. Here. So, this is an interesting one. Okay, so pay attention to number 13. So notice that you have x and y in both expressions here. So this is going to be a little bit tricky. So remember from algebra, when you have two equations and two unknowns, when you have two unknowns, you have to make two equations and use a system of equations to solve. So we're going to go back to system of equations here. And we're going to go back to this a few times throughout the year. But first, let's set up that 56 equals 4x plus 2y. So 4x plus 2y equals 56. Okay, and then the other equation, there are a couple different routes you could take here. But the other equation you could do, say, you could add these two and set them equal to 180. Since you know in a triangle, this is already, 90. You could add these two and set them equal to 90. Or you can conclude that this angle here would be 34 degrees. So this angle would also be 34 degrees. And I kind of like that one better. So let's set 5x plus y equal to 34. So remember from systems of equations, you would have to get it so that one of the variables cancels out by multiplying one equation by a number. So as you can see, the y's, if we multiplied the second equation by -2, then we could get the y's to cancel. So then this would turn out to be negative 10x minus 2y equals negative 68. So let's add those up. So we would get negative 6x, the y's cancel, equals negative 12. Keep trying to put this down. There we go. So then x is equal to 2. And then you would plug that back into one of the original equations. I'm going to just do this one. So 4 times 2 plus 2y, and we're just going to solve for y now. So a plus 2y is 56, minus 8 on both sides. 2y is equal to 48. So y is equal to 24. Okay, so that's all the examples I'm going to show you. The rest will be in your Edulastic assignment. There were just 2 other examples, as well as just the regular homework in your Edulastic. All right, so have a great day, everyone.